So this one all done, right? Let me recall. Once I see the slide, I can feel this is okay. This ancestor. I'm preparing the textbook from this chapter also. Some of the question I recognize. This is maximum number of notes. I think we are on DFS, right? So this is node number properties, and then complete binary tree with n nodes. Jump over. Solve numerical, right? Yeah, that's also good exercise. We can show the slides. So it looks like the TV serials. They make it to recall whatever we watched yesterday. But now it is very good. You can watch the serials daily, right? Today, tomorrow. You can imagine in 90s. Sunday to next Sunday. One TV serial was there, Malgudi Days. You have seen that? Yes. When you saw? So many TV. Yes, so many. You have seen that? Yes. Actually, when I couldn't see the TV frankly because that time my father was very strict. I don't have TV in my home. But just last year only, when I bought my tablet, and I had one of my students who was from NIT for PhD. Then I took his laptop one day and I saw that so many TV serials, movies, all this. Then I told you are doing research or you are doing all these things. Then I take it Malgudi Days from him, and one was Nukkad. You have seen Nukkad, right? Nukkad is also one TV serial. Very. So only I watch. So you have seen in the black and white TV, right? Yeah, good. So the Malgudi Days is you don't remember the stories, right? Malgudi Days you don't remember the stories, right? Very very poor these things. But the writer of the Malgudi Days was K. Narayanan. He is very very famous writer. And he wrote this guide was also written by him. The guide there on movie. Oh, you know that movie also. Really, your general knowledge very strong. So this is here. So this one done right. So it's like okay, good. So that time the major problem is after Sunday again next Sunday, 1 week you wait to forget what you have seen before, right? In this TV serial, but we still I remember we were very crazy. After 1 week also we don't forget anything. Recall, right? This one is done now. This one already finished. Yes. Now go to the depth limited search. Okay. Now the question is, last time we discussed that we have depth first search like this or depth first search, right? And after that, so many sophisticated search we have. And the names I can say iterative, dipping, A star, branch and bound. Many searches are there, but fortunately or unfortunately, all are basically based on DFS and DFS. So basically, we do some modification in DFS and DFS, and then we extend it. So I can say that all the searches are basically derivatives of DFS and DFS. So sometimes, like in our section 1, one student asked the question that what is the difference between depth limited and DFS search? So very difficult to say, because all the searching is basically based on DFS and DFS. So the problem was, if you remember this, take the example particularly if I am here breadth first search. So this fellow always need lot of storage, because once you go to the particular level, then all the nodes you have to put into memory, right? The problem is, the advantage is, like if I'm here and if I want to search this fellow, no problem, it's nearby, so I can save the time. But the disadvantage is it needs lot of memory. If you go to the depth first search, you don't need to put everything in memory. You can, So one method save memory, one method save time. So why not we combine these two together and we try to take benefit. And this one is depth limited search is a kind of that technique. So in this case, what we do is we do the depth searching, like we go one by one, but we make sure that we are not going to cross the particular limit. So we say that, okay, first two depth we search. If no, then again we go to the third depth. Labels by labels we define. Not like, for example, here, if we search for all these two depths, you cannot find any move next. So the benefit is, see that third level, if you use that depth first, like define the depth, then you can find the J bit early, because this particular depth you can finish out. And also, like, always searching is basically we increase the search area. And recent example you can see, MH737 already you couldn't find it, right? The flight. How many days? Roughly 15 days. More than 15 days. And you can imagine that now so much technology we have, right? Google Earth and every Earth. And once people die, then and I don't know where they are. Hopefully, I will be safe next week. So, in that case, you always read in the newspaper, a common term was there. Now, they are going to increase the search. Means, first of all, you have to search from Kuala Lumpur to Beijing area. Then they say now the search is changed to extended to the Hind Mahasagar, like some Indian side. Then they changed to the Perth side. You saw this kind of news, right? You can implement same thing here. This place. Instead of, why not just to make it fix some kind of a label instead of going inside depth, and like one way. So if the problems are very very complicated, so our this kind of search is going to be failed. Unfortunately, this aircraft search is still failed, and you can imagine that all the areas wherever they are taking, they are the graph basically, and one by one, like distance, you can just measure that from the telescope or whatever tools we use, like 1 kilometer. If you can take it, like 1 kilometer is how many meter? Roughly around 1,000 meters. So 1,000 meters, like so one meter. So 1 meter, roughly, if you can just say that 1,000 nodes are there in 1 kilometer, and then you draw a graph basically, and whatever you start searching, either depth first search or breadth first search, right? Then they can cover whole sea, because 1 meter is okay, right? If 1 meter any aircraft or it goes, it can see that what are the things. So you can do some kind of project also if you are interested. Like you have to give next year seminar, like you are very good in graph theory. If you want to write the program, you can come to me. We can discuss. You can, in your holiday, you can just make these things basically. So we can measure the sea from Kuala Lumpur, from flight started, and then we can just create the graph and start doing the depth first searching, and just we can say kind of real-time implementation. Anyway, I don't want to make your life very difficult. So therefore, the slides are very good. Once you have the slide, you don't need to discuss so many things. Please. So in this case, like depth first search may be defined, and here we are going to define the depth limit. So quite interesting. See that depth limit is there. So this limit you define 2, 3, 4, 5, and if the depth is greater than limit, then you just return the failure. Otherwise, again you can go back. So what happens is, since this method is basically DFS, but we modify this DFS, like not like end time, you just make it and you define there, and therefore your time, you can save your time. This is depth limited search. This is the depth first iterative deeping. This search to depth 0, that is root node only. Then if it fails, it go to the depth 1. Then it fails, then go to the depth 2. And if goal is found, it is nearest node and path onto its on the stack. So let us, I have some, take this example. For depth first search, iterative deeping, you see that iterative deeping, the words comes like deeper and deeper, and iterative means like jump, one level down and down, and therefore we use this word called iterative deeping. So consider that we have the binary tree, not the graph. So once it is binary tree, then we know that how many nodes are each level, so our life becomes a bit easier. So take it from each nodes, that is level 0. So take it 2 to power 0, then 2 to power 2, and similarly we get it 1 to 8. So nodes at each level. If I take it, node search by DFS, depth first search. So we start from the first level and then go to the second level. This second level, that is 2. So that is basically second 1 plus plus 2, then these are the numbers we have, right? So see that 2, 1 plus 3, then this 3 plus 4, 7, 7 plus 8 is 15, right? So these are the numbers like we travel and we search it. But once we have iterative depth first search, then we have to travel this much number of nodes. So why it happened? Because once you define the level, iterative dipping, the level you define it means you have to store more nodes, because level means also is kind of a breadth first search. Breadth first search, you remember, if you go to the particular level, all the nodes you have to keep it. So in this case, combine this, we can get the faster result, but this memory requirement is more fast, right? So why not just to draw a diagram? Yes. Okay. Just draw a binary tree and take it only for 3 level. 3 level. Just take it 3 level and just try to get it this up and verify that you are getting these things or not. Then you can understand better. Take it 4 level, please. 4 level. Try to take it up to 4 level. Here the branching factor is 2 only because this is binary tree. Just draw left and right. First level, let's see that first level. Okay, you draw the diagram, right? So, line diagram is not enough. First of all, we start doing searching. So, if you take a DFS, so node first, like first level sure we have one, right? So we go to the second level 2, gentleman is sitting, then 2 plus 3, that is 0. So this one is quite clear, the memory storage. You can see If I go to the second level, it means you don't have to only worry about the second level. You have to worry about first and second both, because you have to store these guys. And that is the reason this first is the first level, and the second and third all together become 3 here. Right? And then you added this become 4. Again you go to the third level. So third level, all you have to store. So therefore, because of that problem, storage is high. We have 502 storage. Right? But the benefit is you can get faster result. So that is, to make it more clear, I have somewhere, but don't worry, I'm going to teach you again searching in the whole, because this one is not searching. Yeah. Since you are teaching binary tree, then again I don't get chance. So this is the branching factor for binary tree is always 2. Let us see the branching factor if it is 4. So what happens if it is 4? 4 means not only 2 children, 1, 2, 3, 4. So first node, then after that 4. So that is 4. Then again go to the, means it will go based on 4 to the power, right? So this one is 1 to 4, 5. This is, so by DFS we get this number. I don't say that you draw because it is very complicated, right? And this is for DFS. But surprisingly, if you see this one, iterative dipping, if the branching factor is very large, then this is 21,000 and we have 29,000. So it's not a big difference, right? Not a big difference. Once you compare with this one, you see, 255 to 502, they just double. But once you increase the branching factor, then we feel very happy. 21 to just double is roughly around 40,000. But instead of 40,000, we have only 29,000. So if you increase more branching, this branching factor increase, this method is quite useful, right? But if it is a binary tree, better not finish this because it will be a huge gap. This is, let us summarize. When searching a binary tree to depth 7, DFS require 255 nodes. Iterative dipping requires searching 502 nodes, right? So basically it's a twice. Iterative dipping takes twice. But whenever we take the branching factor 4, which means 4 children, then it's only 1.33 times. It means we increase the branching factor, then the relative cost will be lower and lower. So you have calculator or not? Then you take the 5 branching factor and just check it back how much it is coming. This one, 5 branching factor. You don't sit in the classroom with calculator. Never ever. In exam, calculator is allowed or not? Yes. So why not to take it in the classroom? No, not for one subject. Anywhere, like you use this. Okay, answer. Just take 5 branching factor. Let us see what is the difference. Okay? Cannot write. Not possible. Don't try. Without calculator, it's not possible. Possible, right? You have. Oh, you have this. Okay, smartphone. Okay, just use it now. Yeah, can. So just I want to see the difference. How much it is coming? This 1, 2, 3, 4, 5, 6, 7, 8. 2 is to power 8. No, 8 level. So 7 level. Just see that what are the difference we are getting. It should be less, I think, less than 1.33. Just try. Understand the question, right? Branching factor is 5. Yeah, good. Right. How much it is? The last one just not last time. How many levels were there? How many levels here? No, don't take it 8 level. How many levels you have taken? 5, 6. Okay, so 6 is. Okay, one student got the answer. So let us see the calculator up to 6 level only. So for just to calculate 6 levels, so from, for example, 1, 2, 3, 4, 5, 6 up to here, right? So if I take it up to here, that is 1365 and 1818. So can you divide 1818 by 1365? I want to see the ratio. 1.2. 1 point? Oh, for this one also 1.33. Oh, it means it is independent. So 1.33. What is your average? Just to get it. What is your average? 1.24. So see that it should be less basically. So once you take it from here, this is 1.33. Once you increase the branching factor, you get lesser. So everyone is get it 1.25 or someone get higher also. I think you didn't understand what I'm saying, right? You understand what I'm saying? How much you got? You didn't. Okay, no problem. It's 1.24. 1.24. You cannot get answer is okay, but at least you know how to do. You know how to do, right? Okay, so these are the things. Other search technique. Very interesting. BFS and DFS are the foundation of all the search techniques. So every technique is basically depend on these two fellows. And surprisingly, we don't have that techniques for you to study. So it's very happy. not cover these more sophisticated techniques. And both are based on these two, but some fundamental we should know that. Both are based on DFS and DFS. We mix it some property and and take it these things. But if you take out this DFS and BFS search. In whole world, we have only two types of search. One is blind searching, and another one is informed searching. So basically, informed and uninformed searching. Informed means, like, if I know that I'm here and there is one city which is 150 kilometers from here and I have to reach. This is just means I have some information about the goal. That city is only 150. Another searching is I have to start from here and I have to go to reach one city. And don't compare now, because now we have Google Map and all, we can find it very easily. Just to consider 500 years back, there was no aircraft. Inside the sea, the Columbus has to go one place to another place. So 150 kilometers is there, that one you can say the cost. So whenever you know that there are some information. So if the distance is more than 150 means immediately you can raise the hand, say that there is no city like this, right? So this is not my city. So you can just take out. That is because you have some little information. The blind searches are like uninformed searches. You don't have any information. You have to search. So these are the two searches are there. And for artificial machine intelligence, did you study artificial machine intelligence? In the MC also no, right? Oh, you don't have to study AMI. Okay, then no point. So for AMI, basically this kind of things is very, very important, because you should know that nowadays the world is moving towards humanless. Means machine is become human now. Everything machine will be doing, and then artificial machine intelligence is very, very important. And like one technique is there, like machine learning kind of things, that we learn, machine also learn. So these things is, you don't have, sure you didn't study, right, in your undergraduate also, and MCA you don't have. Okay. You don't have, right? Okay. So these are the summarize whole lecture. Definition, rotated trees, depth, height, and trees, banded trees. After that, most of the lecture notes basically based on this one, but I have taken some slides from other